I'm going to talk about when to abstract. They just switched the rooms, so if you are looking for the other talk, you have to switch, I guess. Still happy to see so many faces here. My name is Kore. Those pictures tell you very little about me, like I like to cook, eat, I like to travel. But what's more important here right now is what I'm doing when it comes to business. I founded together with Tobias and Manuel Quafu like 6 years ago. We focus on software quality in terms of consulting, workshops, trainings together with our customers. And doing these trainings and consultings, we consult many companies who are using Symfony, and we actually even advocate that because we think it's the most sensible framework to use right now. By doing this consulting, we even do long-term code reviews over months or years together with our customers on top of Symfony, on top of other stacks. And this talk contains some concepts, some ideas we learned during those consultings. On top of that, we founded together with Benjamin Eberlei, who is sitting right in front here, Tightways, a PHP application performance monitoring platform. If you want to learn more about that, ask him or ask me later. We will be around, Benjamin will be around tomorrow the whole day. So, but let's talk about you and the actual topic of this talk. You are a born pattern recognition machine. You are amazing at that, and as a developer, you even enhance this feature of yourself throughout your whole lifetime. You learn and continue to learn, recognizing patterns really, really fast. And by learning or understanding patterns in concepts, you also infer abstractions from that. So if you're discussing a project with a customer, you match patterns, you match what you have seen before, and you automatically infer abstractions which you want to put into code later. So before talking about actual abstractions in programming, I want to talk a little bit about pattern recognition. Humans are born with this ability, and we are really, really amazing at this. So if you take a child, and this comes from studies around this topic, if you take a child and point the child to something like a table and tell him or her, this is a table, if you start with the second table, the child will probably already recognize that and understand, okay, this is a table, even if the table looks entirely different from a formal perspective. And this works with the third table, the child will already be pretty sure about the concept, and with the fourth, even it looks entirely similar, entirely different again, the child will recognize and will learn this category or pattern really, really fast. Interestingly, my brother did his doctor in human robotics, and what they are doing, of course, is a lot of machine learning and stuff like that. And from him, he told me about this nice example. And this is a really, really big problem when it comes to human robotics or robotics in general. Those robotics and machine learning algorithms are really far from the features humans have regarding this. So they are behind by a lot. It will take years until they match our abilities in this regard. So this is very basic pattern recognition. Where does this affect our job? Why does it relate to us? As already mentioned, we do this all the time immediately if we are put into some project. If we are in a discussion with a customer, we immediately match certain patterns. This starts from very basic conditions, like a user may only do that under this circumstances, something like that. Very basic conditional mapping. This continues by extracting from discussions with your customer, okay, this entity has those fields and the type of those fields will be that, and stuff like that. And it continues by matching common software design patterns, and you're understanding that those patterns are extracting or inferring those patterns already when talking very basically about some conceptual software. Architectural patterns are also extracted immediately by you. This is a good thing, of course. This enables us to understand, to structure software, to write sensible software after all. The question is, or the next question is, where should we stop matching those patterns? And this is the topic of the talk. I want to discuss with you, where should we stop matching those patterns? Where does they stop making sense in a broader sense? To discuss this on a sensible basis, I want to separate between different types of software projects we are implementing. So I start with a project, just a common project, something where a customer comes to you and tells you, I want this feature set, please implement that. A very closely defined feature set, like I want a very special online shop, I want something I have in mind, and you implement that. If you implement that, you probably already see some technical patterns emerging, and from those technical patterns, you will use some library for that, or you will even write a library out of that, like, for example, a logging library. Probably most of you are using Monolog for that, extracting stuff like that. There's something else we extract from common project work, and I saw that again and again happening in the last 15, 20 years. For companies, you extract some business patterns and you extract something like a product from that. A product could be a generic content management system. Easy Systems is here, for example. It could be some online shop platform. Shopware is here based on Symfony 2. So you extract something like a product. The important part now is, why I'm talking about this, is that those three different types of projects have entirely different concerns when it comes to abstraction, also regarding other stuff. So let's take a step back and take a look at what do those projects implement. A project, as mentioned, is driven by business, and the business, the customer, drives the use cases, tells you what the use cases are in your platform, and you have to implement those. You might not like those, doesn't matter, you have to implement those. On the other hand, if you take a library, it has a very defined use case. To take the example of Monolog again, it's a logging library, you know exactly what is happening in there, you implement that and you are done. In a product, you have a defined use case, like online shopping or like content management system, and or some user, some agency, some other developers will build on top of that. You don't have to care about all those special use cases. You only build the core. The interesting thing now is, when it comes to extensibility of those platforms, what has to be done on top of that, on top of some initial state, some state you already have developed. In a project, modifications of use cases, new use cases, affect the whole stack. You just changed your project. You just change the way the code is written. You just change how the project will behave. A library sometimes needs simple add-ons. Usually, it already fulfills a certain case. You can also take Guzzle or Buzz as HTTP clients. They fulfill their dedicated use case. They might require some extensions on top of that, like new loggers in Monolog, like some new client library, if there would be something else, and curl for Guzzle or Buzz. A product is different here, and you can probably ask the guys and girls from Easy Systems or from Shopware. Customers will do about anything with those products. They will extend anything, they want to change anything, and they will do the things to your product which the product is not meant for entirely. So how do developers usually react to that? We love to write libraries because we have a very defined use case. We know exactly what will happen there. We do not really like sometimes if the customers always tells us or keep telling us, adapt this use case, we want the product to do something else, we want the project to do something else. We might not always like that, and we are horrified by the ideas customers come up with if you're publishing a product. What is done to that code seems horrific in some cases. Let's step back to patterns. When it comes to pattern discovery or pattern recognition, there's an interesting condition. This condition is called Pareidolia. Let me show you some pictures. This is a toast. Some of you might already see something in there. This is an orange. This is a dog's butt. Sorry for that. What do people see in there? They see Jesus in all those three pictures. Pareidolia is a condition of over-recognizing patterns, recognizing patterns where they actually do not exist. They do not really exist in there. So yeah, people wanted to see Jesus and just had a toast in the morning, put the toast in, got the toast out, and saw Jesus on there because they wanted to see Jesus for some reason. They believed in that and they wanted to see that. This is a disease I see a lot in our field. Like, if I learned about the new pattern, the other talk right now is CQRS, for example. I learned about CQRS and I immediately see that in every customer requirement. This is just it, I want to implement that. So let's talk about that. And I already also talked about discovering business patterns. There's one more thing I have to say regarding that. As a developer, you might discover a business pattern at some point. For example, if your customers always require you to implement something of some kind of management of content pages, you think, okay, this is a content management system, let's make a business out of that. A remark there. As a developer, we do not always, or we tend to underestimate what business people are doing. We know that we know more about software development than about business development. Probably the business people also know more about business development than about software development, and more about the business development than we know. So we might want to trust those regarding development of business cases, business use cases. On the other hand, I know that lots of developers try to anticipate what will happen in a product and build abstraction layers before they are actually needed and before the use case is there, and try to anticipate what will happen with our software. And we just learned about Pareidolia. This also happens, so we should be careful regarding that. Having said all of that, what should we do with this information? Just one other fact. Business requirements will never converge. This means if you have a set of business requirements, you see them, you implement them, you come up with an abstraction which implements them in a nice and clean way because you think the next business requirement you'll get will be similar, and I will be able to implement that with the abstraction layers I already came up with. This will never happen. At least it never happened to me in the about 20 years I'm now in software industry or now doing software. And it makes sense that this happens at least very, very seldom. The world is really complex and far more complex than software or the constraints of software are. We live in a world where we know how compilers behave. The entire world is far more complex than that. And a new customer with new requirements for our product or project or library will try to enter the market with a different angle because he or she wants new clients. So they will always have to come up with new ways the software should behave. So business requirements will diverge always. This directly leads us to advices on how to implement software and how to abstract in software. And this is now finally the part where we get to instructions on how to write software. This sentence might come as a surprise, because we always learn about those layers, layered architectures, maybe hexagonal architectures, but always something like that. You have the database layer or persistence layer, you have a model layer maybe, you have a controller layer, a view layer, and stuff like that. Now I'm saying split vertically instead of horizontally. What do I mean with that? I get a new use case in my project, whatever. I want to implement, or I should implement some user registration, just the common thing via email and password. So people should be able to register. This usually affects all my layers, like view, controller, services, storage, whatever I have there. I go through all those layers and implement this kind of stuff. From the very beginning, I might also be aware of another feature very similar to that, like registration through, or users should be able to log in using some single sign-on mechanism with a different storage system, using LDAP, using Facebook, or stuff like that. What we as developers do in this case, we immediately try to build an abstraction layer which covers as much as possible of those two use cases, because we see similar constraints in both cases, and we want not to repeat ourselves. We want to implement that in a generic way, both ways. What happens if this third use case comes in? You will probably not be able, or you will never be able, to reuse all the abstraction you have already built. So you're reusing a little bit of that. With the fourth use case, with the fifth use case, the same thing happens again and again. And in the end, you have a very small part of the abstraction layer you are actually able to use. The problem with that is that the abstraction you came up with initially required refactoring, and the refactoring was probably harder than if you just would have written the code plain without any abstraction layer at all, because you always have to refactor the abstraction itself, the code using the abstraction, and the side effects which causing all the other use cases to break. So what this means is, maybe regarding business cases, you should start with implementing a use case purely vertical. Just implement this use case entirely separated from the other use cases. Write code, duplicate code in the second use case maybe, and wait creating abstractions. Avoid pareidolia when creating abstractions. I like that word. So never abstract before you have seen the second, the third, maybe even the fourth use case of something. Never abstract before you actually get a good idea of the overall problem, of the problems which will come. If you understand after the third, fourth, fifth use case what the overall domain is you are working in, your customer tells you to work in, then maybe create an abstraction layer which works with all those parts. The other thing with all those use cases usually is that in a business world, none of those use cases is fixed. They will change over time again and again. And this also has implications on the abstraction. If those use cases are split vertically, the code is split vertically, it's usually easier to change. I'm not saying, yeah, let me stay with me for a while and we get back to that. So what I'm saying right now is duplication is better than wrong abstraction. A right abstraction is a great thing, of course. And I personally love and really enjoy that feeling if I'm coming up with an abstraction beforehand and the next customer requirements matches this abstraction exactly and I can just plug it together and everything works. I love that. But if I'm thinking about what I did through the last 20 years, this happened really, really seldomly. I forgot to ask one question a lot of slides ago. Who of you, I told you about the separation of writing libraries, writing products, generic products, and writing projects. Who in here spends most of his or her time writing libraries? It's like 3 people, 4, 5, 6, 7. Who of you in here writes uses most of their time writing products? Who in here uses most of their time writing projects, like coming up with new projects for the customer? This is interesting. I would have expected, so to give you the numbers, it's about 50%, I would say, on products, 40% on projects, and 10% on libraries, maybe 5% on libraries, something like that. I would have expected the count for projects to be a lot higher than on products. So, but stay with me for a while, for a bit longer. Coming to one of the most important concepts for domain-driven design. When talking about value objects, regarding abstraction, value objects should only, from my or our point of view, contain something which can be called eternal truth. So value objects should only contain truths which will never be changed. This is entirely different, again, for each of those type of product or project you are working on. In a product, there is almost no eternal truth. There's nothing customers will not modify, at least if you're talking like online shopping systems, content management systems, even an online shopping system, simple things like email validation, like a price must always be positive, will not be true for all the customers using your product or extending your product. There will be no eternal truth. which means, on the other hand, there's almost no code or no logic you should be putting into value objects. There might be some eternal truths in libraries, even though it's also limited, I would guess. But in projects, on the other hand, they just implement your use case, the stuff your customers want from you. It's usually not reused by many other people. It's probably a lot of eternal truths encoded in the project, which does not require regular changes. So for projects, we advise customers to put logic in value objects, for example. And if the domain of the customer changes, if there are new rules introduced, you might be able to change just those domain objects or still extract easily the code which is in there into something like a service validator or stuff like that. So this is one point regarding value objects. Yeah. I have another point regarding facades or proxies or wrappers around external libraries, services, or stuff like that. From our point of view, they are good or they are okay if they simplify multiple use cases in the usage of externals, so external services, libraries, stuff like that. So if you only use some external service, like a newsletter registration service, a payment service, or stuff like that, in one single place, just keep it in there from our point of view. Especially if you're working on a project, it's different for products, of course. Just keep it in there. If there's only one single service used, write the code there. It's still easy to refactor out later. If you're using a service in multiple places, feel free to implement a facade. I prefer talking about facades instead of proxies or wrappers in here, because one crucial aspect to me is at least to model the wrapper from a usage point of view. So how do I want to use the payment service in all my code? So this is the point of view, or this is the constraint under which I want to model my wrapper. And this is usually called a facade in this case. If you are using such an external in multiple places in your code, you will have a solid understanding of what is required from this external service library or whatever in your application. And in this case, you can write a sensible facade for that. You won't be able to write a sensible facade from the very, very beginning. If you're doing product development and you know beforehand, like, I implement only this one payment service in my application, but I know customers will want to implement different other payment services. I have to analyze that in depth and come up with a sane API for that. And this will not be an easy task. We probably always should also in this case just always implement 2, 3, 4 different endpoints or integrate 2, 3, 4 different externals to be sure you understood the problem correctly. If you take a look of how many iterations it took to come up with a standard for HTTP libraries like PSR7 it is right now, how many iterations it took to come up with the same standard for that. It shows how hard it is to really model such a wrapper in a clean way. So be careful with that. I mentioned that if you're using this external only in one place, it's still easy to refactor out. And regarding refactoring, this is really important when talking about maybe not abstracting too much. What is the essence of this talk? One other point, do not implement the next generic query mapper or something like that. Yes?
How would you write unit tests with an external library?
Yeah, so the question is, how do I want to write unit tests with an external library? That's true. It depends. Sometimes you have to write a facade, a simple facade, just to be able to write sane unit tests. This is correct. Sometimes it depends on the externals you're using. Sometimes it's just fine to use the externals, or maybe this is code you do not want to test anyways because it's something close to control or something. This varies. Sometimes it's just necessary to write a facade just to be able to unit test. This is correct. So getting back to refactoring, or the joy of refactoring. We recently noticed that we love to refactor code, even really, really ugly legacy code. We love to do that. And Toby pointed out to me why this is the case. Legacy code already contains all the stable business logic. So if you're going to some client who has a horrible source code base, but it's some kind of online shop or some kind of system which powers a company with tens or hundreds of employees, and they are earning money with that, you know this is a code base which is really, really valuable for a lot of people. And it contains all the business logic. It will be hidden somewhere and hard to discover and hard to test and all this kind of stuff. But it contains the business logic to power this company or to power this product. And what you can do in this case, you can, by refactoring, have patterns emerge from those code bases. And this is something we love to do. So you go into this really, really ugly code base. We are just right now with a customer who still uses something like index.php files all over. And in every index.php file, they are generating HTML using SQL, using SOAP and stuff like that. And they are multiple thousand lines long. But they are powering a solid company with that. They are a European market leader in their area. So it's a product which powers the life of a couple of hundred people at least. So what we are doing then, we are teaching them on how to refactor code and, of course, also how to goal to refactor to and stuff like that. The other idea you could have is, of course, a rewrite of such horrible code bases or hard-to-read code bases. But studies show that when doing a rewrite, you usually lose like 40% of the domain rules or the domain logic, which is encoded in such a product. Rewrites are a lot harder than everybody thinks. Nobody in any company with a well-aged product knows what the code actually does and knows about all those side effects, so you will lose a lot of them. When refactoring, this is a little bit critical at this point, a developer could almost do domain-driven design without explicit domain logic. All the domain knowledge about the domain is already contained in this legacy code. And you can just keep those patterns emerging from the code, and you will not lose knowledge about that. In all other cases, it's called domain-driven design. So the domain drives the design. You are not able as a developer to do domain-driven design yourself, at least if there are some business people involved or you do not know everything about the domain. There's no way you are doing that on yourself. And from my point of view, you should probably not use some patterns from some of those really, really interesting patterns from domain-driven design without intensive talk with the domain owner or people who really know the domain really well and analyze the domain together with you. But when refactoring, all the knowledge is already in the code, and you can do something like that on yourself. So about refactoring, in this case, and if we're doing what I'm talking about here right now, refactoring is and must be default behavior. In every pull request you make or in every feature you implement, you will also refactor code and bring it to a stage where it is cleaner than before or adapts to the world or to the domain you are implementing in a saner way. You refactor every time it makes sense from my point of view, and we do that with our customers. This, of course, also means if the domain changes, the code changes. This is obvious. The next question, of course, is when shall I refactor? When is the stage that code looks so ugly or bad that I should take it and change it and refactor it and take some time to move it to cleaner patterns or cleaner ways of implementing the logic which is in there? The more you wait, or the longer you wait, the more you know about the actual domain which is implemented in the code. On the other hand, the longer you wait, or the more technical depth occurs and the harder it gets. So it's the same with testing for me. We do not tell customers to test every line of code. Test the important parts of your application, which means infrastructure code, which of course means code which is important to your domain, like code which earns a lot of money, code which is crucial to earning money with your product or powering whatever your product does. And the same is true for refactoring. The crucial parts, the important parts should be clean and refactored, and you should be able to understand and read them easily because then there will be less bugs in there. But if you're coming up with a new feature, with a new prototype, don't recreate all the abstraction layers. Test it first if it makes sense for your domain, and then at a later point, once you understood the domain and once you understood what you have been implemented or what you want to implement, then start refactoring it to something you already understood. To sum that up again, I separated or told apart between libraries, projects, and products. When it comes to extensibility and writing or using design patterns, focusing on extensibility, in a library you of course need that. If I'm using some library for a certain task, like Monologue, like a template library or whatever, I want to be able to extend the important bits. For Monologue, it usually means I want to implement custom formatters, I want to implement a custom logging backend or something like that, but I do not want to restructure how the library works. In a project which you write just for one customer, you do not need this kind of extensibility. If the domain changes, you just change the code and adapt the controller service, whatever you have there. And it's easier actually if you did not abstract it too much beforehand. In a product, you need all the extensibility you can get. Customers or users of your product, people who extend your product and use it for something else, for something custom, will adapt and change anything what is implemented there. Again, ask the guys from like Shopware, from Easy Systems, from WordPress or from PHP-BB, like Nils Adermann, for example, ask them about that. People will change anything. And this is why the extension mechanisms in products like Oxid, WordPress, PHP-BB look so horrible from a software design perspective. They must enable people or developers to change anything in there. Regarding API stability, from a library I expect maximum API stability or maximum backwards compatibility. It must not break and it must never break. In a project, this is again not that important. Of course, there will be code which reuses other code, and there will be common usage of some classes, some interfaces in a project. But usually I can also refactor every usage of some bit of code easily together with the API changes. So it's okay to change APIs in projects. In products, surprisingly, people usually do not care that much about API stability. They're used to features backwards compatibility breaks in products. Because when people extend anything or everything, there's no way to continue to develop your product other by breaking some stuff sometimes. There's no way around that. So people are not used to that. On the other hand, in a project, you must focus on modifiability of your product. As mentioned in the very beginning, your use cases will change. There will be new use cases which you did not anticipate beforehand. So we must focus on maximum modifiability. The modifiability in a library, because it's usually a very defined and closely defined use case, there will not be so many modifications like in a project, and not as many modifications like in a product. Product, of course, also need modifiability, of course. So what do we want to focus on in those parts? In a library, please optimize for stability with the possibility of customizations. If I'm using a library, I want backwards compatibility all the time and forever. So focus on stability, allow customizations. In a project, on the other hand, optimize for change, because this is what will happen there. There won't be this one, a lot of people extending a certain thing in your application. The use cases will change, and you should optimize for that. This takes us back to splitting vertically instead of horizontally. I want to be able to optimize, to change those use cases, adapt those use cases to business requirements, and not create some beautiful abstraction layer in there. When talking about products, it gets more complicated. Writing products, from my point of view, is the hardest thing you can do. Is you have to optimize for modifications. People should be able to change how the overall product behaves. On the other hand, you need a stable core. Otherwise, people will abandon your product anyways, because if you're changing the core APIs all the time, people will not like that if they have written modules on top of that. So I expected that most in here will do project development. This is why I'm putting a focus on that. Optimize for change in project development. If you're developing a project which just one customer uses, or for just one customer, optimize your code for change. And in this case, I'm even bold enough to say do not abstract. Do use abstractions really, really carefully. You are not Symfony. If you're doing Symfony development, which is product or library development, something's in there, in between there, more library development to me, you of course need abstractions. I want to be able to change anything there. I want to be able to adapt how the core behaves, how stuff is parsed, how stuff is rendered. I of course want to adapt that. I want to reuse certain functionality, but I want to be able to integrate that with my use cases. If you're just doing project development for one customer, do not fall into the trap of reusing the beautiful patterns you see in some library code, you see in product code. Do not fall in that trap. Do your stuff, implement it just bottom to top or top to bottom, and don't come up with abstractions too early for that. There might be some point where it makes sense, of course. There might be some point where abstractions are really, really sensible for your project. But don't start with that. Don't do that too early. Thank you for listening. One more, yeah. We blog about stuff like that, topics like that regularly on the Quafu blog, and there is a newsletter where you can register, and there was a blog post, for example, which was also titled Do Not Abstract, I think. So if you're interested in this kind of topics, feel free to register with our newsletter. We have like 2 minutes left, so if there's one good question at the very end, I would welcome it very much. Maximilian, yeah, go for it.
When you're talking about extensibility, you're talking about polymorphism or hooks, or is there any difference between them?
So what kind of extensibility I'm talking about, like polymorphism, subtype polymorphism, like some hooking mechanism. There's also single slot, there is event handling and stuff like that. I don't care about those in this talk. Generally, subtype polymorphism is a beautiful thing. Use that if you can. Sometimes we just need some kind of domain events. Sometimes you need pipes and filters. Sometimes you need something else. Hooks is not clearly defined, but mostly some mixture of some signal slot mechanism plus pipes and filters or stuff like that. This is an entirely different discussion. Use whatever makes sense in this clean object-oriented code. So, yeah, we have one more question, or time for one more question left. Is there another one? Then, yeah, go for it. So what is about the idea that many software development patterns promise changeability? Yes, they promise that, but I think more from a library perspective. So sometimes you want to be able to change certain parts, starting with interfaces and then all those patterns we just mentioned, like signal slot and so on. They promise that it will still be easier if you just code it bottom down to change that to new customer requirements, because every time you use a pattern, you're anticipating where the code will be changed or how the code will be changed, and this might not be true. If we were able to forecast that, we might want to join the lottery, because we would earn more money that way than developing code, of course. So every time you come up with some software pattern for changeability, you actually bet on that the code will have to be changed in that way or in a certain way. So sometimes you might be right with that, and I love to be right with that, but most of the times I'm sadly not. So yeah, I hope this answers your question. The time is up. Enjoy the coffee break, and thanks again for listening. Oh, I have stickers here. If somebody wants Tideways or Quafu stickers, feel free to grab some. Thank you.